Good afternoon. My name is Mugilan Selvarajan. My matric card number is CD190032. I am going to present about the introduction. Casting is a steel item produced via way of means of alloying molten steel and just solidify in the mold. The shape of item is designed via way of means of the shape of the mold cavity. Casting is a method includes a interaction among such a lot of parameters along this melting temperature of charge. The mold condition, temperature, moisture content, sand and kind of binders used. Pouring temperature and the getting design. The variant in the most of those method parameters from just sit can have an effect on the feed and the effect on the crystal formation. In every other word, the distinction with inside and moisture of the casting can end result because of the non-uniform cooling of the molten steel with inside of the mold. In casting, especially sand casting, it is hard to preserve this regulation due to the problem controlling its method parameters. Therefore, it is hard to supply a casting with a uniform moist structure. Numerical simulation is a powerful tool for investigating the various physical phenomena that occur during the casting process. It provides information on the fluid flow, heat transfer and solidification. The goal of such simulations is reduce scraping, use less energy and thus improving casting by shortening the design process of optimizing casting parameters. Shrinkage is the measure flow in the sand casting and is frequently the cause of casting rejections and rework in the casting industry. Shrinkage is the reduction of the casting size during the transition of the liquid and solid state. However, the likelihood of its negative effect on the casting can be reduced. As a result, it is common casting defects and take appropriate steps to minimize them. As a result, it is one of the most effective modeling tools in the casting industry. Aluminium is the maximum not unusual place detail with inside earth crust and exists aluminum oxide. It processes a few strange houses together with the excessive resistance of corrosion, ease of fabrication, excessive thermal and electric conductivity, low weight and brilliant color. Alloys are aluminum may used to packaging in the mill industry, manufacturing pistons, cylinder head, some of in the combustion engines and electric cables study. Thank you.
Assalamualaikum and good day. I would like to present about chapter 2, literature review of our project. My name is Muhammad Hazmi Bendo. The first thing I would like to talk about is the simulation program. In order to evaluate the defects, we need to use the simulation software to improve the casting quality and minimize the shrinkage defects. The optimum way is to produce components through the casting process with the least defects, and the only way of zero defect possibility is through controlling parameters like the composition of an alloy, melting and pouring temperature, getting design, molding and solidification rate. The software that can be used in this simulation program is like AutoCAD, ProCAD, Click2CAD, Stephen and Macmosoft. Sandcasting is widely used in industries and it applied because of the low cost material that used in the procedure, which is sand. And sandcast aluminum components are widely used in the automotive and transportation industries, including aerospace. And there are parts commonly produced with sandcasting include the powertrain, supports, suspension, casings, gear and many others. Here are the example of products that produce from sand casting, uh, which is widely used in automotive industries. For example, in a car, there are suspensions, gears, engine crankcase, and the powertrain that you can see on the right side. Here we can see the advantages and disadvantages of sand casting. And the advantages of sand casting, we could see here is simple production process, have low cost casting mold, lower production cost, wider material choice, high complexity shapes, and short lead time. And on the other side is the disadvantages of sand casting, which is handmade process, have low strength, low dimensional accuracy, have rough surface quality, more casting defects, and unstable casting quality. In our project, we would like to focus on the defects of the sand casting of an aluminum alloy.
Assalamualaikum. My name is Muhammad Karafi bin Johan. My metric number is DD190007 and I will be explaining about the theoretical modeling. Okay. In theoretical modeling, the sand casting is distinguished by its own unique process and features than any other types of modeling process. Sand casting can be used to make metal castings using non-reusable sand molds. Sand casting can even make complex exterior design with fine details. According to Christian Cavallo, a researcher, sand casting is one of the methods that has the ability to shape metal without having to perform machining process, and casting can produce a near shape product. This enables for mass production to produce a quality, affordable, and durable product using sand casting. Okay. For 3.1.2, components in sand casting mold are divided into four. The first one being the base sand. The base sand basically create the mold into its purest form, and it is necessary for the base sand to stay in the mold. The second is binder agent, which acts as the agent for keeping the sand particle intact and in place for further sand casting process. And then the third is the additive to enhance the mold surface strength, cushioning, and finish. And the last is parting compound, which uses fine liquid or powder to maintain pattern removal from the mold. There are many types of application of sand casting, which is to build an engine block, medical equipment, automobile component, mining parts, hardware, gear and bearing, and so on. For the gating and feeding system, it is a metal pouring device that direct molten metal into the mold cavity. There are four main reasons for a gating system in sand casting. The first is filling the mold cavity with enough metal in the least amount of time without raising the metal temperature. The second is flowing the molten metal smoothly to reduce the turbulence and air trapping when casting. Third is the gating system determines the optimum temperature range so that shrinkage occurs in the gating system rather than the casting pieces during the metal cooling process. And the last is combined with a technique for removing metal contaminants. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Shamsuddin. I want to continue the experimental modeling of our project. Much of the expense of aluminum permanent mold casting is the machining and shaping of the mold, which is normally made from grey iron or steel, with the requirement and component geometry separated into two halves. The mold is formed into the geometric shape of the brain part. The mold two sides are firmly sealed through the injection process to prevent the presence of air or other impurities. Prior to landing or injecting the molten metal into the mold, it is heat. After the procedure is complete, the mold is allowed to cool so that the metal portion can solidify. To stop faults from forming, the component is swiftly removed from the mold after cooling. Okay, we can see the method of permanent aluminium mold casting, that is pouring and solidifying. Okay, we continue to design numerical experimental analysis. The base material in this work is AlSi5Cu3, and solidification simulation for sand casting was performed in the AutoCAD 11. AlSi5Cu3 alloy was chosen due to this numerous applications in fields such as automotive, marine, defense, and transportation. It is because there is high mechanical properties such as hardness and tensile strength. Because of its good mechanical properties and favorable casting, this alloy is used to manufacture automotive components such as engine crankcase blocks, petrol and oil tank, tool handles, and so on. The freezing point of AlSi5Cu3 alloy is 100 degrees Celsius. Thank you.
Hello, my name is McDaniel Anademian, metric number CD190202, and I will explain on the experimental setup and component setup. Visualized mold pouring and solidification are part of the casting simulation. Based on the thermal properties, the solidification behavior is examined from the external zone to the core region, leading to the identification of the defect. Feeders are provided in three locations with varying from dimension, where shrinkage is most likely different. Dimensions have been applied to feeders in order to account for defect-free casting and material waste caused by fettling operation. Feeder dimensions have been optimized for each geometry as shown at Table 3.4.1 and Table 3.4.2. Table 3.4.1 is the feeder dimension and Table 3.4.2 is the modulus of feeder. To eliminate shrinkage defects, three adequate feeders are located at the top of the leftmost, rightmost, and the middle portion, while metal is poured through the middle feeder by direct pouring method for all three geometry varied cavities with excellent feedability. Tables 3.4.1 and Table 3.4.2 show the dimension of and modules of three different feeders provided to respective cavities. Figure 3.4.1, 3.4.2, and 3.4.3 show cavity filling for 8 mm, 12 mm, and 16 mm thick plates respectively. The temperature range was investigated in relation to casting yield and quality. An approximate amount of volume solidifies after filling the cavity and was also examined. Figure 3.4.1 is pouring of molten metal of 8 mm thick cavity at various depths, while figure 3.4.2 is also pouring of molten metal, but it is 12 mm thick cavity at various depths. this is the result that we obtain based on the software that we use. I will continue the presentation to my friend. That's all from me. Thank you.
Assalamualaikum and salam sejahtera. My name is Muhammad bin Azman with number matrix CD200138. Today I'm going to present the conclusion that can be made from this project. Investment in casting technique will reduce on the job testing and try out in favor on computer-based design and analysis, which significant impact on energy and the environment. Improved technique capacities will also reduce defects, post-casting operation and rejected casting, as well as save energy and lower environmental emission. According to the study, more data and equipment are required to improve casting design and casting technique, which include alloy properties and performance data, as well as accurate casting performance simulation based on alloy properties, stress level, and solidification integrity. All numerical modeling studies have contributed to increased steel product quality, elimination of defect in alloy product sale, and reduced risk of error. They will aid in the production of better product at a lower cost and with less energy. Reduce on the job testing and try out in favor of computer-based design and analysis. That's all from me. Thank you.